distinguishing between. This is one kind of question which you cannot afford to miss out for your upcoming ISC exam. Your paper has to have at least a few questions, or maybe minimum one question on distinguishing between. Now, like in your SEM-1, you had distinguish between primary, secondary, and tertiary alcohols. And when this kind of question was asked, what would children write? I mean, some children, not all of them, some children will write that OH is connected to a primary carbon, OH is connected to a secondary carbon, OH is connected to a tertiary carbon. For God's sake, this is not what is expected. What is expected is you need to give a chemical test, a chemical reaction in which there is some odor or some visible thing which is happening, so that you can identify which one is, if then in that case, primary alcohol, secondary alcohol, and tertiary alcohol. Well, alcohols is not there for your SEM-2. Okay, so for your SEM-2, we are having, say for example, ethanol and propanol. Now, how will you distinguish between ethanol and propanol? Now, that's the question. So now here you need to look at the structures. First thing is you need to draw the structures. So here you draw ethanol, CH3CHO, or you can also write it, of course, as CH3C double bond OH. And in this you need to identify whether there is an alpha methyl group. So here there is an alpha methyl group, and in the other case, in propanol, there is no alpha methyl group. You can see that there is a beta methyl group, but there is no alpha methyl, and the alpha methylene is there, but alpha methyl is not there. And that's the reason. Now, how you can identify? So any two pairs, now the moment you get this pair, draw the structures and try to check whether both of them are having alpha methyl group or not. So if one of them is having alpha methyl group and the other one is not having alpha methyl group, then you can go for a test which is called as haloform test. Okay, haloform, also known as iodoform to be specific. Okay, we're going to use the iodoform test. Moreover, ethanol or acetaldehyde is the only aldehyde which is having an alpha methyl group. Other aldehydes do not have an alpha methyl group. So let's go for haloform test and quickly see how we are able to distinguish between two compounds in which one is having the alpha methyl group and the other one is not having alpha methyl group. So we're going to add NaOH. So in this we are going to add a total of 4 NaOH groups. I could just write the number 4, but for you to understand, I am writing it in detail. So here we are having ethanol plus sodium hydroxide plus iodine. Okay, so we'll require 3I2. If you want, I'll split this also and write it as 3 iodine in this format. Okay, so now what's going to happen? These 3 sodiums will first combine with these 3 iodines to form 3NaI. Okay, 3NaI, sodium iodide. Then what's going to happen is this remaining 3 iodines will combine with CH and these 3I. Okay, CH and 3I will combine to form CHI3. That's how you come to know that this gives you a yellow color. That's how you come to know that this compound was having an alpha methyl group, and that's why we've got the yellow color. Okay, this is giving you CHI3. Okay, what's happening with the remaining things? So this ONA from here, ONA and this HC double bond O will also combine to form HC double bond O ONA. That is nothing but sodium formate. Now we are left with H and OH here. So H and OH will give you 1 H2O. H and OH will give you 1 H2O, and these remaining 2 hydrogens, you know, remember we had 3 hydrogens over here. Out of 3 we have utilized only 1 over here. So out of 3, if 1 is utilized, 2 are remaining. These 2 hydrogens and 2 OH groups will combine to form 2 more water molecules, and hence you will get 3 water molecules over here. By the way, this is important. Okay, this yellow color of iodoform is important. That's how you will be able to distinguish between ethanol and propanol or any other compound which is not having an alpha methyl group. Okay, now let's move on to the next distinguish between, that is propanoic acid and propanol. Now here propanoic acid is CH3CH2 C double bond OOH. So this is a carboxylic acid and this is an aldehyde. Okay, so CH3CH2 CHO, I can simply write it like that. And if you add Na2CO3, sodium carbonate, to an acid, obviously you will be able to see effervescence. Now CH3CH2 COONA plus CO2 carbon dioxide, bubbles will be obtained. So effervescence of carbon dioxide, the moment you see effervescence of carbon dioxide, you identify that it is an acid and not a aldehyde. So if you are having two test tubes, okay, and in both the test tubes you put Na2CO3, here there is no effervescence, here there is effervescence. So you understand that this is propanoic acid and this is propanol. Okay, I hope that's clear. And if you further want to confirm that it is carbon dioxide, just take a moist blue litmus paper. It will turn into red, and the moment it turns red, you identify that it is carbon dioxide, and yes, it is hence propanoic acid. Let's quickly see the next distinguish between acetaldehyde and acetone. Now have a look over here. You cannot use haloform test in this case because both of them are having alpha methyl groups. So can I use a haloform test? Not at all. Both of them are going to give me yellow color. So I cannot use haloform test for distinguishing between acetaldehyde and acetone. Now what do I do? So this is an aldehyde group, this is a ketonic group. So you know that aldehydes are okay with oxidation, but ketones resist oxidation. Okay, ketones resist oxidation. So we are going to use this property and quickly identify acetaldehyde. We're going to perform Tollens reagent. Okay, test with Tollens reagent. What is Tollens reagent? Tollens reagent is ammoniacal silver hydroxide, or also sometimes ammoniacal silver nitrate. In this case we are using ammoniacal silver hydroxide. Then this will react with acetaldehyde and quickly oxidize it to form CH3COO, almost acetic acid, but here it is forming ammonium acetate. Okay, 2 moles of ammonium acetate will be formed. Okay, and here silver will get precipitated, and when silver gets precipitated on the inner walls of the test tube, you can see a silver mirror test. That's how you can distinguish between acetaldehyde and acetone. Acetone won't be able to oxidize and displace silver, okay, and silver will not form a silver mirror test in case of acetone, but it will form a silver mirror test in case of acetaldehyde. Okay, I need to complete the reaction, is it? So this will give me further 2 moles of ammonia plus water, yeah, 3 moles of water. So this is how you will complete the reaction. Okay, and you will be able to distinguish between aldehyde and ketone. So any aldehyde and ketone you can quickly distinguish using either Tollens reagent, or you can also go for Fehling solution. Now what is Fehling solution? Fehling solution is a combination of Fehling solution A and Fehling solution B. So Fehling solution A is consisting of copper sulfate, and Fehling solution B is consisting of sodium potassium tartarate. Okay, so but we are not going to write the entire big reaction, we're just going to write the ionic reaction. So here we are having acetaldehyde. Okay, acetaldehyde CH3CHO plus we are going to add Cu2 plus. Okay, I'm just writing the ionic reaction, plus 5OH minus, and it is going to give us what? It is going to give us CH3COO minus in the ionic part. That means here you can see that aldehyde is oxidized. When aldehyde is oxidized, this cupric ion is going to convert into Cu2, which is brick red in color. The moment you see